Alright, so we can use this as a guideline for Inky's chase mode behavior. So let's start. So we'll open up Inky's blueprint. So we'll first of all save everything, open up Inky's blueprint, and under chase mode, this is what we can do. So we'll go ahead and call the event once again. So event. So I believe it was called mode change or something. And we are again going to do a switch. So under chase mode, we have to determine what to do. So under chase mode, first we need Pacman's location. So get game mode ref. Again, the same way we got Pacman. So we have access to Pacman now. And using Pacman's reference, what we can do is we can go ahead and get his location. So get actor location. Alright. So this is going to be Pacman's location. And now we need to find Pinky's target tile. So Pinky's target tile is pretty easy to determine. So what we can do is we can do one thing. We can head into Pinky, and over here where we have the destination, we can store it in a variable as well. So we can promote this to a variable. So I'm not sure if we have a target location in our parent class, but since this is the only case we'll be using it for, let's just store it in Pinky. So we can call it target location. We can call this particularly Pinky target location. Another way you can do is you can also store it in your parent class as well. That is probably a more extendable way, but since we are remaking Pacman itself, it shouldn't really matter. We are not going to be using this anywhere else. If required, we can go ahead and change this. So now every time we update this, we are going to change it basically. And this is going to be Pinky's target location. So what we'll do is we'll get Pinky and we'll get target location. So get Pinky target location. Whoops. Get Pinky target location. Alright. Now we have both of them. So what we have to do is we have to take the position of Blinky. So let's get Blinky and let's call get actor location on him. So we have the location of Blinky and draw a vector from Blinky to Pinky. So that's going to be Pinky minus Blinky. So Pinky's target location minus Blinky. So this is going to be this vector, whatever it's asking for, draw a vector, and we need to double the length of this vector. So we're going to multiply this by 2. So what we'll do is we'll multiply this by 2. Alright. So the target is at the end. So this is basically how we are determining this. So I'm not sure why it asked for Pacman's location. Okay, so it's not Pinky's target actually. So we don't really require this. So let's go ahead and remove that. So it's actually 2 tiles. So we'll use the logic once again. So we'll do the same thing over here. So instead of 400, we'll just use 200. So we'll delete this variable as well. So this is going to be into 200. And this is the target location. And we're going to multiply this by 2. So get the forward vector, and we also got the Pacman's location. So this is done over here itself. Alright, so I guess this should be good for our logic. So this logic is supposed to work. So I hope it works as expected. Alright, let's just go ahead and do a bit of cleanup over here. So just move this up a bit. Alright, so plus and subtract it over here. And once we subtract it, we can multiply the vector by 2, and this is going to be what we require. So from Blinky to Pinky's target tile. So this is what we have to do. Of course, if you want more accurate representations, you can prompt more and maybe you can look it up. But for our purposes, we are going to do this much. And if we are in chase mode, what we'll do is we can again set a timer. So we can set a timer by function name. And what we can do is update target and chase. So we can call this, and again we can have a duration of 1 second, let's say, and set it to looping. So we can call this update target timer. Alright, and what we can do now is on the other modes we'll see what to do. So this is the location, so we can just call AI move to. Since this is a looping timer, everything is going to handle itself. So the pawn is going to be self, and this is basically what we want.